Hello class. If you're watching this video, maybe you missed a day or maybe you just want some extra review. I did teach this lesson in class, but I wanted to upload a video just in case you need a little extra review. So today we're working on section 7.1. 7.1 is the introduction to the systems of equations chapter. And it's introducing that we can solve these systems of equations, two variables, by graphing. And that at its base, systems of equations really is finding the intersection of two lines. So our goal is we want to solve both equations, and we're going to solve for the xy pair. So for the xy pair, that's true for both. For xy pair, that is true for both. We'll talk about what that means as we solve. So let's take a look at, I think, just 2 on this little worksheet. Maybe we'll start with 13. 13, we have 2 equations here, which are clearly both in slope-intercept form, so they are ripe for the graphing. So here, I have a y-intercept of 4 and a slope of down 1 over 1. I'll just make a bunch of dots because, as it turns out, in order to solve these systems of equations by graphing, we need to look for the intersection point. So graphing this line, starting at -8 as a y-intercept, going up to over 1, we see, it looks like these lines intersect right at right at over 4 up 0. Do you see how that point is included both in the blue line and in the red line? It's an intersection point right here. So that means that 4, 0 is the solution because it is included in both lines. And remember, this should make both equations true. So let's plug the 4, 0 pair into both equations. They should both come out true. 0 is my y, 4 is my x. So 0 equals -4 plus 4. And the question is -4 plus 4 actually equal to 0? And the answer is, of course, yes, it is. So this point made the first equation true. Nice. Plugging it into the second equation, 0 for y, 4 for x, is 2 times 4 minus 8 actually equal to 0? Well, 2 times 4 is 8. 8 minus 8, yeah, that's equal to 0. So the point also makes the second equation true. So since my x-y pair made both equations true, I know that I got the right answer. 4, 0 is my answer. Let's just do one more example. I think you get the point. In number 15, it looks like we do not have these equations in slope-intercept form. We could use intercepts method here, but I don't know. I think it'd just be easier to do slope-intercept form. So here, let's subtract x from both sides. So -y equals -x plus 2. I'm trying to isolate the y here, because if I can isolate the y, then it'll be in slope-intercept form. Next, let's cancel this negative in front of the y by dividing through by -1. This gives me y equals x minus 2. Okay, good. Now the y is isolated. I have it in slope-intercept form. -2 is my y-intercept, and I can go up 1 over 1. And down 1, left 1. All right, I think the second equation is a bit easier. All we need to do is subtract the x, because there's no negative in front of the y, so I just have y equals -x minus 8. All right, so I have slope-intercept, y-intercept of -8, and I'm going down 1, left 1. That goes off the graph pretty quickly, so we need to go in the opposite direction, and I definitely see the intersection point. It looks like the intersection point is that left 3, so x of -3, down 5, so y of -5. And again, if we plug this into our equation, they should both end up being true. So I'll check my answer of -3, -5. I could plug it in here or here, but let's plug it into the original equation just because it's easy to see. Plugging it into this equation, is -3 minus -5 equal to 2? Well, yeah, because the double negative becomes positive. -3 plus 5 is equal to 2. So this first equation is good to go. Second equation is -3 plus -5 equal to -8. And yeah, it obviously is. So this equation is also true. So systems of equations, I'm looking for the xy pair that is the intersection. And since it's the intersection, it will make both equations true. Ta-ta.